Okay, so let's look at an actual example here. So again, if speaking more generally isn't up your alley, hopefully looking at concrete examples will help. So usually I'm better at starting at concrete examples rather than speaking generally anyways. So here we want to determine the coordinates for point P on the terminal arm of angle theta in standard position in the fourth quadrant, such that cosine of that angle in standard position is just 2/3. So that's the ratio for that's the cosine ratio of that angle in standard position. And we know that the distance to the origin, the distance of the origin to point P is just 7 units. So the distance of the origin to point P is 7 units, and we know it ends in quadrant 4. Hey, let's actually just draw a picture here, because pictures, for me, pictures always help. So we know that we want to end or terminate in quadrant 4. And so here we go. So we have some angle, theta, in standard position. And it says that there is some point P on this terminal arm. So there's some point P. And this point has coordinates. So what are the x and y coordinates of this particular point on this particular terminal arm of this particular angle in standard position? Okay, so that's really what we're solving. Usually it's nice to draw triangles here. So what do we know about this? Well, we know the distance of the origin, or the distance from the origin to point P, is 7 units. So where's the origin? The origin is always where the x and y axes cross at 0, 0. So the distance from the origin to point P is 7 units. What does that really mean? That really means that's our r value, right? The radius of the corresponding circle that we could draw, or the hypotenuse of this right triangle that we've drawn, is 7 units. I will erase that angle in standard position just because it's getting a little messy. So, and there we go. So, what else can we do? Well, we can simply write cosine of theta is equal to 2/3, and we know that cosine of theta is also equal to x over r. So we know that when x is 2, the r value is 3. So we can say when x equals 2, for this particular angle in standard position, r must be 3. And we also know that in this particular case, where we want the x value of this particular point that's 7 units away from the origin, we know that r isn't 3, it's 7, right? So we can say 2/3 equals some number x over 7, where the ratios are constant, right? This is called setting up a proportion, right? So a proportion is just some statement of equality between two ratios. What we really mean here is that if the ratio between the x value and the corresponding r value, if the ratio between the corresponding x value and r value is 2/3, but we scale up our radius to 7, then when we scale up x, we should still get the same ratio out. So these two ratios should be equal. So what will the corresponding x value be? Let's take a look. What we can do here is solve for x by cross multiplication, or we can just multiply both sides by 7. So here, if we just multiply both sides by 7, the factors of 7 cancel. Got to multiply the left-hand side as well. So we can say, therefore, x is just 14/3. So what do we have here? We have the x coordinate for this point. The x coordinate is 14/3. There we go. Now, what else can we do? Well, we can find the corresponding y value. When x is 14/3, what is the corresponding y value? So we have another piece of leverage. that we can use here. And that's called the Pythagorean theorem because we know the hypotenuse of this right triangle, we know the base length of this right triangle. Sorry, it is 14 over 3. So what we can do is we can leverage the Pythagorean theorem, x squared plus y squared equals r squared. X is just 14 over 3. R is just 7. So let's plug those values in. So x is 14 over 3. R is 7. And let's calculate this. 14 times 14, I think, is 196. And 3 times 3 is 9. Plus y squared equals 7 squared, which is 49. Now we want y, so we're just going to subtract 196 over 9 from both sides. So minus 196 over 9, minus 196 over 9. Let's make some space here. We'll move a little bit further to the right and rewrite our statements. So this fraction is canceled. On the left-hand side, we're just left with y squared equals 49 minus 196 over 9. I want the same denominator for both of these fractions, so 49 over 1. To get the same denominator, I can just multiply the top and bottom by 9. So 9 times 9. And what is 49 times 9? Well, 9 times 9 is 81. 4 times 9 is what? 36. So that should be 441. So here we have y squared equals 441 minus 196 all over 9. And we'll make some room here. And what is 441 minus 196? This is, I should just be doing this with the calculator because we really have minimal time here. But I don't know where my calculator is. So let's take 1 away from here. We have 31 now. We're borrowing from this tens column here. And what will we have? We'll have 5, and then 3 minus 9. Well, 3 minus 9 doesn't quite work without going into negative numbers, so we'll borrow again from the next column over, from the hundreds column. And so this will be 13. This will be 13 minus 9, which is 4. You're just watching me doing elementary subtraction here. And then 3 minus 1 is 2. So we should have y squared equals, what is this, 245 over 9. And do they have any of the same factors? 2 plus 4 is 6, plus 5 is 11, so no, they don't. So what we can do is we can take the square root of both sides. Here we go. So taking the square root of both sides is actually a key step here. You might think, oh, Mr. Peterson's just going through another simple algebraic step. Well, I am, but really, remember, when we take the square root of both sides, we take the positive and negative square root of both sides algebraically. Usually when we're dealing with geometry problems, we simply take the positive or the principal root. But in this particular case, we won't, because we're dealing with geometry, sure, but we're dealing with geometry on a 2D coordinate plane. And on two-dimensional coordinate planes, we can have negative y values. And in this particular case, we should have a negative y value because this particular y value, it's below the x-axis. So when we take the positive and negative roots from both sides, in this particular case, we will prioritize the negative root. The negative root is the only root that will actually make sense for this particular question with these particular constraints. So here we have y equals the negative root of what is, how can we simplify this? This will just be 245 over square root of 9. We know that square root of 9 is really just 3, so it's going to be over 3. And 245, we're going to have to do a little factor tree here. We can divide both sides by 5 if we like. If we divide both sides by 5, what are we going to have? 49. Hey, and then 49 is a perfect square. So this is really just going to be square root of 49 times 5. I'm just going to do this step by step because I realize it's probably been a while since a lot of us have simplified radicals into entire radicals into simplest mixed radical form. So here I've factored the radicand into a perfect square times some other factor. And this is simply just going to be the square root of that perfect square times the square root of that other factor. And the square root of 49 is 7. So this is 7 root 5 over 3. So that is the y-coordinate. Whoa, boy, what a lot of work that was. Definitely could have had a simpler example for this particular question, but there we go. Let's actually dive deep with something significantly difficult. So here the y-coordinate is what? It's negative root 7 over 3. There you go. Sorry, negative root 7 over 3. Negative 7 root 5 over 3. You can tell it's been a long day already for me. So what are the coordinates of point P? For some terminal arm theta in standard position that terminates in quadrant 4, such that cosine of that angle in standard position is 2/3, and the distance of the origin to the point P is 7 units. Well, the coordinates of point P are 14 over 3, a rational number, and negative 7 root 5 over 3, an irrational number. Now this is definitely not an easy question by any means, but there you go. This is an example of a more difficult kind of 6.2 kind of question.